The last thing we need to get our cannon working is to make sure it's drawn on the screen. Like our background texture, we will make this happen in the Draw method, so scroll down until you find it. You'll see the code you wrote from the last time we drew a sprite. That was background texture. We're going to make another call to SpriteBatch.Draw. This time, a little more complicated than the call for the background texture. So, after the line where you called SpriteBatch.Draw, add a new line, and then the following. SpriteBatch.Draw, open parenthesis, cannon, .sprite, comma, cannon, .position, comma, null, comma, color, .white, comma, cannon, .rotation, comma, cannon, .center, comma, 1.0f, comma, sprite effects, none, comma, 0, close parenthesis, semicolon. It may look like a lot of code, but it's only one method call. There are just a lot of arguments. Let's go through each of them. The first argument, cannon.sprite, is the stored texture 2D inside our cannon game object. The second argument, position, is the position we set for our cannon game object. 120 units from the left side of the screen, 80 units from the bottom side of the screen. The third argument, null, is an optional argument that takes a rectangle. It is meant to provide a way to draw just a piece of an image. If our cannon image was a lot of different images all in one file, arranged in a consistent way, such as a grid or strip, we could use this optional argument to animate through the different images by just drawing a piece of the larger image. By passing null, however, we instruct the XNA framework to just draw the entire image. The fourth step is a color tint value. Like with background texture, we use color.white since we don't want any particular tint. The fifth argument is a rotation value. This is where cannon.rotation comes in. The sprite will be drawn rotated by a radian value equal to cannon.rotation. Since this value changes if the player moves the thumbstick or presses left or right on the keyboard, each frame this value can change, so the cannon will appear to rotate smoothly. The sixth argument, cannon.center, is used to specify the origin of rotation. Think of this as a fixed point the sprite will rotate around. If you specify an origin of 0, 0, that will make the origin the top left corner of the sprite, and that corner will be fixed while the rest of the sprite rotates around it. That's not what we want. We want the cannon to rotate around its center. So, in the constructor for the GameObject class, we calculated the center and stored it in the value called center, which we pass in here. The seventh argument is scale, a multiplier used to make sprites look bigger or smaller than the source image. Since we want it to be the size of the source image we loaded in, we set it to 1.0f, 1 times scale. The eighth argument gives us the chance to flip the image horizontally and/or vertically. We chose not to do either. The ninth and last argument is a depth value. Objects with a lower depth value, closer to 0, draw in front of objects with a higher depth value, closer to 1. In this way, we can have sprites stacked on top of other sprites to give the illusion of depth. We want this sprite to be right up front, so this argument is set to 0. That's all we need, so let's compile and run. Click the right green arrow or just press F5. Make sure you're at the Connect to Computer screen if you're using the Xbox version of this project. Great! The cannon is displaying on top of the background image. Now, use either your Xbox 360 controller's left thumbstick or the left and right keys on the keyboard to rotate the cannon. Notice that it rotates around its center and can only rotate as far as 90 degrees before it stops. In the next chapter, we'll get some cannonballs in the air. If you're ready to move on, click the next chapter.